So let's suppose that we have an object that moves along the y-axis so that its location is given by f of x equals x squared plus x, where y is measured in meters and x is measured in seconds. We're going to start by finding the average velocity from 2 to 4 seconds, and when we see this word average velocity, really this is the same as the average rate of change, so I want to apply that formula. F of 4 minus f of 2 all over 4 minus 2. So before we hop in, we might want to figure out what is f of 4 and what is f of 2. F of 4 in this case would be 4 squared plus 4. So I have 16 plus 4 gives me 20. And f of 2 here we have 2 squared plus 2. So I've got 4 plus 2 gives me 6. So in my numerator, f of 4, we said that was 20, minus f of 2, we said that was 6. All over 4 minus 2, that's 2. I've got 20 minus 6 here, 14 over 2, which would give me 7. And remember, we just found average velocity here, so we want to make sure that we include a unit. It says y is measured in meters and x is in seconds, so I think meters per second is probably a pretty good choice for units. Part B, we've got a very similar question. It says find the average velocity for x changing from 2 to 2 plus h seconds. So here I want to find f of 2 plus h minus f of 2 divided by 2 plus h minus 2. So some of this we can actually do. F of 2, we found f of 2 earlier. We said that was 6, so it's going to be something minus 6 divided by, in my denominator, 2 minus 2. Those two are going to be canceled. The only thing I'm left with is h then. So really it's just f of 2 plus h. This is the new thing. This is the thing I've got to go find. So let me do that in red here. F of 2 plus h, we're plugging that into f of x, which remember, f of x we said was x squared plus x. So this will be 2 plus h, quantity squared, plus 2 plus h. Again, remember this guy, you are going to have to FOIL that out, so if you need to, take a step to write 2 plus h times 2 plus h plus 2 plus h. So let's see, if we FOIL this guy out, we should end up with 4 plus, let's see, I should have 4h plus h squared plus 2 plus h. So, oh my goodness here, let's see, 4 plus 2, I've got 6. 4h plus h, I should have plus 5h plus h squared. And that is my f of 2 plus h. So here I've got 6 plus 5 plus h squared minus then that 6. Well, hey, look at this. 6 minus 6, those two will cancel. And oops, you know what I forgot? This is my mistake here. Here I've got 4h and h. I forgot my 5h right here. That's why. I was looking at that and I was very concerned. Some of you might have been yelling at your computer screens, and if that was you, I'm sorry. I apologize for that. So what we're left with then here, we've got 5h plus h squared, all of this divided by h. Let's go ahead and, I see that common factor of h in the numerator. Let's go ahead and take care of that. Let's do that in blue just so that we don't get confused with this work. Factor that h out. That leaves me with 5 plus h divided by h. These two cancel, and I'm left with just 5 plus h. So hey, that's pretty cool. I found the average velocity from 2 to 2 plus h seconds. Part C, and oops, you know what I forgot? We said average velocity. I should say really 5 plus h meters per second. If we're talking about velocity, I should include a unit here, so we'll say meters per second. Part C, we want to find the instantaneous velocity at x equals 2 seconds. So here when I see instantaneous velocity, and really anytime you just see this word instantaneous, we should be thinking about the derivative, f prime of x. So I want to know, hey, what's the value of the derivative at x equals 2 seconds? And actually, if you look at this work, we've actually done quite a bit of it here. We've actually found up here, we started this process. We said, okay, I want to find the average velocity from 2 to 2 plus h seconds. Think about what does the derivative do? Well, the derivative takes this number, this h, and it makes it smaller and smaller and smaller. It moves it closer and closer to 0. So really, that's the only new part of this that I need to look at here. I need to look at, okay, well, what's the limit as h approaches 0 of my average velocity I just found in part B? Well, that's 5 plus h. And okay, we evaluate this. We just plug 0 in for h. 5 plus 0 gives me 5 meters per second. So that's how fast the object is moving at exactly x equals 2 seconds. So this is just kind of a quick example to show how the derivative applies to velocity and how kind of those two things, I almost want them to mean exactly the same thing. When you think of velocity, you should also be thinking about the derivative. All right, let's look at one more example here. This one's a little bit tougher, so we'll take our time. Here we've got f of x equals 1 over x plus 2. So, okay, let's start. We're going to find f prime of x. We're going to find the derivative, so I'm going to start by finding f of x plus h. So I really only have the 1x. It's going to be 1 over x plus h plus 2. Well, I can't simplify that anymore, so that's it. There, we're done with step 1. So that was easy enough. Step 2, I want to subtract my original function. So I'm going to take f of x plus h, what I just found, minus f of x. So what I just found, 1 over x plus h plus 2, minus my original function f of x, which is 1 over x plus 2. And here is where we run into some trouble. We've got these two fractions. I look at that, I say, boy, it would be pretty nice if we just had one fraction instead of two. And of course, we know that, hey, if we're going to subtract or add two fractions, we need a common denominator. So unfortunately, you might look at this and say, well, x plus h plus 2 and x plus, those are pretty similar already, right? Can't I just take out the h or something like that? And unfortunately, because this is plus h, we're not multiplying by it, they're actually quite different. There's not much we can do, and actually the fastest way to get your common denominator, I'm going to multiply this fraction on the left-hand side by x plus 2 over x plus 2. And on the right-hand side, I'm going to multiply by the denominator of the other term, which was x plus h plus 2 over x plus h plus 2. So don't worry too much yet. I'm going to show you what happens here. It's actually kind of cool. So in my numerator here, x plus 2 times 1, well, that's just x plus 2. So, okay, that's not too bad. Your denominator, I'm actually going to tell you not to FOIL that out. Don't worry about multiplying that. I'm just going to leave it as x plus 2 times x plus h plus 2. Minus over here, now I'm looking at 1 times x plus h plus 2, but 1 times anything is itself, so here I have x plus h plus 2 divided by x plus 2 times x plus h plus 2. So here, the one thing I will warn you to be careful of is this minus sign right here. Be very, very careful of that. It's really, really easy to make a mistake. I'm going to take that minus sign and I'm going to distribute that to each term in my numerator here. I think that's a little bit easier to kind of consider. And now I can look and see, okay, well, I've got x plus negative x. Well, those two cancel. 2 plus negative 2. Well, those two cancel. So what am I left over with? I'm left over with negative h divided by x plus 2 times x plus h plus 2. Cool. And at this point, I would say, let's go ahead, let's move on to step 3. We've combined these two fractions into one single fraction, which is really all I wanted to do here. Step 3, let me do this, let me change up my color here. I'm going to take what I just found, f of x plus h minus f of x, take this whole thing and divide it by h. So I'm going to take what I just found, opposite h divided by x plus 2 times x plus h plus 2 divided by h. Holy moly. We got fractions in our fractions. That's just no good. That won't do. So I would think about that denominator as a fraction. I'm going to think about that as h over 1. Think about, okay, how we really have a fraction up here in our numerator divided by another fraction in our denominator. Well, how do we divide by fractions? The way we divide by fractions, we multiply by the reciprocal. So I'm going to multiply by 1 over h instead. In the denominator, these two are going to cancel out. And in my numerator, hey, look at this. I've got a factor of h right here. I've got a factor of h right there. I can go ahead and cancel those two things out. So what am I left with then? Negative 1 in my numerator divided by x plus 2 times x plus h plus 2. Cool. I've gotten rid of that h in the denominator, which is really what I want to do in that third step. My last step then, step number 4, step 4, I'm going to take the limit as h approaches 0 of what I ended up with, negative 1 over x plus 2 times x plus h plus 2. So really all I'm doing is plugging 0 in for this h right here. So I'll have negative 1 over x plus 2 times x plus 0 plus 2. I'm just going to write that as x plus 2. So we could probably just leave it like that, or maybe we write this as negative 1 over x plus 2 quantity squared. Again, you could FOIL that out if you really wanted to. Whoops. But let's say that this is our derivative, f prime of x. So that one was a little bit more involved, and this is, now we're moving into kind of the more difficult derivatives to compute. Anything that starts off looking like a fraction, it is just going to be a little bit more work, just because we are going to have to find a common denominator. But that's it. We've got our derivative, which is good. Part B here, it says we want to find f prime of 3, so I want to take 3 and plug that into my derivative. So f prime of 3, I'm plugging that into my derivative, negative 1 over 3 plus 2 quantity squared. So negative 1 over 3 plus 2, I've got 5 squared, that's negative 1 over 25. So cool, I evaluated my derivative at 3. Lastly, similar to the last problem we looked at in the previous video, I want to find the equation of the tangent line when x equals negative 1. So again, just to outline what we have an x value, we have 1 comma blank, we're going to need a y value, and we're going to need a slope. So let's start with the y value, why not? So let's start with the y value here, and remember, for the y value, I want to plug this negative 1, this x equals negative 1, oops, forgot my negative sign, and plug that into my original function. I'm going to plug that into f of x. So f of x was 1 over x plus 2. So here we're going to have 1 over x, which is negative 1 plus 2. This is 1 over 1, which gives me a positive 1. So my y value here is positive 1. This is my y value. To find the slope of the tangent line, so to find this guy right here, I'm going to point and think about the derivative, because the derivative is what tells you the slope of the tangent line. Just like we said earlier for like derivative and velocity, I want derivative and slope of the tangent line to sort of be linked in your mind. So if I say slope of the tangent line, you think the derivative. Those two things almost mean exactly the same thing, but not quite. But we'll just say that those two things are linked. If you think of one, you should be thinking of the other. So if I want to find the slope of the tangent line, I'm going to take -1 and I'm going to plug that into my derivative here. So f prime of -1, this is -1 over -1 plus 2 quantity squared. So -1 over, let's see, this is 1 squared, -1 over 1 gives me -1. So my slope is -1. At this point, I have everything I need. I'm going to go ahead and plug this into my point slope form, which remember, that says y minus y1 equals m times the quantity x minus x1. So y minus my y coordinate we said that was 1, equals m, that's my slope, that's the slope of the tangent line, so that's -1, times x minus my x coordinate was -1. So we could probably, let's solve it for y. I usually solve it for y just to get it in slope-intercept form. So minus a negative I know is plus a positive. Y minus 1 equals -x minus 1. Add 1 over, here I have y equals -x. So this is the equation of my tangent line at x equals -1.